Welcome to the Module 9 exam review. I believe we're in part 6 now. So we're picking up at number 33. We have x is less than 4 or x is less than 6. So we're going to go ahead and graph and solve this. Now x is less than 4. There's 4. X is less than that. We're down here. X is less than 6. There's 6. We're going down here. Now with an and, we're looking for the overlap. But with an or, we're saying any part of the graph that's colored is part of the solution set. So the solution set, this would be negative infinity all the way up to 6, not including 6, or it's really just x is less than 6, because that includes everything that we need. Okay, so that's that one. Now taking a look at the next one, we're looking at 9x minus 6 is less than 3x, or negative 4x is greater than or equal to, less than or equal to negative 12. So we're going to solve these individually, graph them, and then come up with the solution set. So here I'm going to move 9x over, minus 9x, minus 9x. Negative 6 is less than or equal to negative 6x, divided by negative 6. So we get a 1, flip the sign. X, so here we have x is less than or equal to 1. So go ahead and graphing that. Solid dot at 1, x is less than or equal to that, so we shade down there. Solving this, we divide both sides by negative 4. So we get x, flip the sign once again. When we divide by negative, negative divided negative is positive, so if x is greater than or equal to 3. Solid dot at 3, x is greater than or equal to it, so over there. So we have x is less than 1 or x is greater than or equal to 3. This is the graph. That's the set notation. The interval would be the negative infinity to 1, including that, union 3 to infinity. So any of these are acceptable solutions on the examination. So now moving to the next one here, we have negative 3x plus 1 is greater than or equal to 7, or 4x plus 3 is greater than or equal to negative 13. So once again, isolating these for the variable, subtracting 1 from both sides, we get negative 3x is greater than or equal to 6, divided by negative 3. We get x is less than or equal to negative 2. So graphing this, dot at negative 2, x is less than or equal to, we're down there. This one, subtract 3 from both sides, so you get 4x is greater than or equal to negative 16, divided by 4. We get x is greater than or equal to negative 4. Now, negative 4 is over here, or greater than or equal to. So it's there. Because we have an or, we're looking for anywhere that's colored up by the line. So that would be negative infinity to positive infinity. That is, any number works, or all real numbers. Those are the solutions to that right there. Okay. So, got those. So and we're looking for the overlap, or we're looking for anything that's lit up by either of them. And now we have some absolute value equations. So absolute value 5x plus 4 equals 10. And then we'll look at 4 times the absolute value of x plus 1 minus 1 equals 2. So here we want to isolate the absolute value. So subtract 4 from both sides. The absolute value of 5x is equal to 6. Now, this is going to be true if what's in here is 6 or what's in here is negative 6. So there's the two cases, the positive case, 5x equals 6, divided by 5. And one of our solutions, x equals 6/5. Now there's also the negative solution when 5x equals negative 6, divided by 5. And we get negative 6/5. So these are the two solutions to that equation right there. Looking at this one over here, we want to isolate the absolute value again. So we have plus 1, plus 1. So we have 4 absolute value of x plus 1 equals 3, divided by 4. So the absolute value of x plus 1 equals 3/4. So once we've isolated this absolute value, we want to consider the positive and negative solutions. That is, this could be 3/4, so x plus 1 equals 3/4. Or we have the negative solution, x plus 1 equals negative 3/4. So here, you subtract 1 from both sides. Cancellation, x equals. Now, this 1 is really, we could say that's a 4 over 4. So 3 minus 4 is negative 1 over 4. So this solution is negative 1/4. Here, when we subtract 1 from both sides, once again, we can think this is negative 4 over 4. These cancel. So negative 3 minus 4 is negative 7 fourths, and those are our two solutions to that absolute value inequality. So we're going to have two solutions. It's not specifically that the solutions, one of them's positive, one of them's negative. Like notice here, one of them's positive, one of them's negative. It has nothing to do with that. It's we have two cases, one with the positive number, one with the negative number. This one has both negative numbers, but they're both solutions to that problem that we just looked at. So the next one we have is this. Absolute value of 2x minus 9 equals negative 4. Now, if you put something into the absolute value and it's positive, it comes out positive. If you put something in absolute value that's negative, it comes out positive. So there's no way that we can have the absolute value of anything equal negative 4, which means there are no solutions. Or the solution is the empty set. That's another way we could say that. And then finally, this last one, we have the absolute value of 5s plus 4 equals the absolute value of s minus 6. Once again, we have positive and negative solutions, even though we have two absolute values. The positive one, we leave them both positive. So we have 5s plus 4 equals s minus 6. That's our positive one. Our negative one, we just make one of the two sides negative. So I'll say we have 5s plus 4 equals negative s minus 6. Solving this, I'm going to subtract s and subtract 4. So I'm getting my s's to the left, my numbers to the right. 5 minus 1 is 4, so we have 4s. The 4's cancel, equals, over here, the s's cancel. Negative 4 minus 6 is negative 10. Divided by 4. And we have s equals negative 5 halves. Once we simplify that, negative 4 tenths. Over here, we need to distribute. So we have our 5s plus 4 equals negative s plus 6. So distribute here and here. So I'm going to add s to both sides. So once again, moving my s to the left. Subtract 4. So I'm moving my numbers to the right. 6s, the 4's cancel. Here, the s's cancel. Equals 2. Divide by 6. And here we get cancellation. And we get 2/6 or 1/3. And those are the two solutions to that one right there. So those are the absolute value equations. Once again, and we're looking for where the things overlap, or we're looking for where anything happens. Absolute value equations are actually ors. We'll come back to absolute value inequalities and the systems of linear inequalities in two variables, and that'll be the review.